couple questions. Great. What can sometimes
Yeah. Jamie, do you mind if I'm sorry, did not plan well for this at all. Do you mind if I kick you off at the share for just a second and say
introduction, right?
Yeah. So we're past our 5:30 start time. Thank you for those that are here. Thank you for the couple that are online. We appreciate your attendance. I want to call out that, for our continued meetups and staying engaged, we've got some social media places that we'll keep you on. We've got a LinkedIn group that you can join, and a Slack channel that we would love to have you join in to stay in touch. Linda and I are, we hope, getting to a point where we can have some capture the flag events starting next year, where we maybe compete against other OWASP chapters. The best way to learn about that will be to join our Slack channel.
And speaking of, I will give a shout out. So it's through Command and Control. They're doing a free event with me Ben starting on Friday. So if anybody's interested in that, I can drop the link in our Slack channel as well.
And if you're watching this after the fact, or you're one of those people in the room who maybe has some space, I work at Asurion, have worked here for a long time, have people that I know that can help me get space. That's why we're here. But we'd love to branch out and go beyond just the Asurion facility, so we can start to reach a larger group. If you'd like to talk and you have something interesting to share, like, we appreciate our vendor sponsors always, but it's mostly supposed to be about our community in the area. If you have a talk, please share with us. We have a paper call that we can send you to, or Linda and I as leaders can help, review those things too.
I will again encourage you. We're always on Slack as well, so you are in the Slack channel. You can chat with us there, or LinkedIn on LinkedIn last one.
So last thing, and I'll pause so we don't skip over this slide. Some of our attendees, I think, are double booked every Wednesday, and this community, the NashSec community, is why. They had the spot first. I think Linda and I were the later ones to the group, but we want to make sure moving forward next year that we don't overlap with their schedule and that we're not going to conflict on the calendar. So we'll adjust so that we're not every second or third Wednesday, to make sure that we can go visit their community just as they would come to ours. But we want to encourage participation with them because I think they're doing the same for us, so that 2026 we can go to both places. Thank you for joining. I don't want to take any more Jimmy's time. We really appreciate, Jimmy, that you're here. And thank you, SciCode, our sponsors for today.
Sorry. Hey, thank you very much for welcome. And welcome, thank you. I appreciate it. I'm excited to be here. For the remote attendees, thank you for joining on the recording. So either listening on YouTube later on. Thank you. So yeah, here we talk about today's session is going to be around future-proof your security for 2025 beyond. One of the drivers is kind of the AI change. How to some many things about that security. Before we get into the agenda, think about myself. I'm a professional, but I've been a practitioner in space for 20+ years. So a lot of the problems come from my practitioner experience. Don't look at everything. My first half of my career is in the public sector in the US. DoD, I got out. I worked with consultants, solution architects, ran some consulting practices, focused on DevSecOps, security, cloud security. Also worked on being an advisor for UC firm, UC firms, text. So what kind of text in asset space? So it's getting started right now. Work right now in full studio at Cycle, but today's topic is going to be fairly neutral. But really thinking about help us summarize on where we have been the last 20+ years, Snapchat. We focus on what we think about this, what we really how the landscape has changed in the last few years. So really, there's some practical insights what we need to move forward. So a couple of things about this topic today. I'm going to talk about some historical trends, market trends, shaping state, current state of AppSec. You've not really anything practicing a lot of that, but you know, I try to put together, tap together a theme that's hopefully easy to see the correlation between the evolution of software development to the evolution of software security and where they converge, the trends and how we should look at it. So I always talk about like where we're at to where from 2000s to 2025, what that journey looks like. And then you think about what do you do going forward? Obviously, I was talking to the audience earlier, sitting here, some folks are starting their career or getting to AppSec. One of the things I would want to challenge everybody is that when you want a new paradigm, I can use AppSec, everything you learn from cybersecurity AppSec might be learn a little bit, you know, might be controversial. But we kind of think about, forget about the legacy, the way to think about security in this case, you know, there's a reason why we do this. Do you want to transform AppSec? So it's very different when you look at Microsoft spec versus cybersecurity. We're going to talk about what that means. And then one of the things that I shared is that, you know, my role current previously is to work with a lot of clients. So here's some practical use cases related. A AppSec program going forward is really funding the free funding use cases. How do we have to incorporate looking at a risk landscape with a big board and modern application stack? How do we actually focus on getting issues? How do we work on different backlogs? Those are practical use cases. I'm going to use real data to show you all some of the things that we see from our customers' environment, right? Very vendor neutral. I work for a vendor, but this talk, I might be using some references, some screenshots, but this is not a vendor pitch, but really show you the data that we detected from our customer environment to show you, hey, what does that look like when you see all these AI applications? What should you be looking for in terms of risks and what you should do to mitigate? So exciting things embedded into Easter eggs is what do we actually see? What does it mean by a modern application? AI application, what kind of things that we see that mistakes people make, like, oh crap, what things we should be looking for. With that, let's get started, right? So before we talk about AppSec, software security, we have to understand the changes, evolution of software development in the last 20 years. So just a quick overview, right? Just think about the journey here, right? We have, you know, from a legacy, on-prem, thick client, waterfall, right? Things that takes a year to release to, you know, about 25 years ago, when we started the Agile manifesto, started to speed up development, being lean. And then obviously, fun fact, 2006 is when AWS started with the EC2 S3. Very much back then, there's not much going to cloud, but just kind of the inception of programmable infrastructure, which is, you know, one way they can think about how do we turn infrastructure into the same way we develop software, deploy software. And then the thing that changed the world, right? The whole about DevOps, DevSecOps, shift left started off with the famous Phoenix project in 2012. And from then, this explosion of moving fast, right? Moving fast at development, moving fast in releases. The moving fast is one of the reasons why we kind of challenge the way we do security, because we don't want security to slow down, right? 3 years after the Phoenix project, people realized, holy crap, we might need to have a special emphasize security, because it's not as easy as putting security as part of DevOps. That's why the DevSecOps really started in 2015. How do we move fast, make sure security keep pace with move speed of DevOps? But about 5 years after 2015 to 2020, we've seen some attempts of people trying to do shift left, people trying to do security in DevOps, and there's a lot of lessons learned, right? A lot of some success. There's a lot of lessons learned of
things didn't go so well, right? So part of that has a couple factors I'll talk about, but then before people figured out, okay, what is it they have to do differently? There's another, I'll call it step on the gas pedal, acceleration, is the adoption from cloud to cloud native. And that's when you think about like container, right, Kubernetes, like containerized technologies, when the people actually not only they are refactoring apps to the cloud, they're not just lifting, shifting application, on-prem application to cloud, they're actually building cloud native apps, right? Everything is containerized, everything moves really, really fast using, technologies like Kubernetes and serverless technologies and GitOps, right? Treating everything as, treating infrastructure automation as part of software development practices. That further have challenged how we do security, how we do app security in a way that doesn't slow down development, doesn't piss off developers, mitigate risk, right? How do we do that? So you see acceleration. If that's not worse, right? And then we have, 2002, 2003, that's when the first time we're hearing about the LLM, right? The co-pilots, GPTs, the explosion of that. Also, it's also worth noting, I'll show you later example in my practical case study. That's when the machine learning, AI, big data, right? Data engineering started happening. So what that means is not only that we actually moving towards more of a AI and data lake, big data, you have people writing code. We're not even talking about like AI generative code. We're talking about data scientists. We have big data analysts writing code, right? So you don't have traditional developers writing code anymore. You got these people who might be expert in their field of big data, but they not be good developers. So factor those in terms of software risk. And fast forward 2025, right? What do? Vibe coding, right? And so just think about the journey and think about the challenges AppSec. I always say, if, there's a lot of things that we need to do differently, but everything you see here in the last 25 years is about speed up, speed up, speed up, right? The more we speed up, the more of like the legacy process that's like doesn't scale, it's more exposed now, right? So we got to do something different. So give example. So looking at the app security, nothing much changed, right? Since we in an OWASP event, right? The first OWASP top 10 was written in 2003. Not much have changed, right? Different versions changes, same challenges. And you see in the 2015, the first attempts of moving to DevSecOps is basically retrofitting your workflows of doing 90 scans, retrofitting some of the scanning artifacts once it's built, moving to the left, break the build. Everyone wants to break the build, but you break the build, but you also broke developers' trust when you don't do it properly, right? And then you have a lot more supply chain attacks too. I think in the 2000s, right? The SolarWinds happened, and all the way up to every year it seems to be this supply chain issues, like Log4j, right? And then this year, how many people have heard the NPM attack about yeah, so, right? And then in March, TJ Actions. How many heard about TJ Actions? Okay, you see, so much issues, right? So not only you gotta move fast, gotta make sure we, things keep up speed, but now we have more attack surfaces, right? And there's also exploitation of AI code assistance, MCP, right? Model context protocol is the end all be all. So we live in a very different world in 2025. Hopefully you see that something got to be done differently. We got to we got to change how we approach it. My experience as a practitioner, a lot of times, it's very difficult to complete pivot your approach. Sometimes it's like, okay, let's just plug a hole at a time. But we're at a point right now, we got to think about things differently, right? So what does that mean in 2025? Our organize it this way. How should we look at AppSec risk profile in 2025 and beyond, given all these things, right? So the way to think about it is, let's think about different layers of risks for software, right? So there's the obvious aspect of code artifacts, right? Code artifacts in 2025 does not just mean the custom code that developers write. Developers write very, very minimal code, right? Yeah, you can use vibe coding, the code generator generate AI code, but that's still very small portion, right? There's APIs, right? Which is also just application without a front end. Open source libraries been around for 10 years now, right? More libraries. Even there's a lot of AI generated code are imported as form of libraries, not necessarily by the code prompters. Like Hugging Face is a good example. There's a lot more AI libraries that's been written by somebody else, questionably secure, being imported to the code. There's obviously a big issue with programmable infrastructure, right? Containing images. Still, you can download Docker Hub. A lot more malware found in these public places that sources contain images. Infrastructure code templates. If you go on AWS or these cloud providers, you download sample IAC templates how to deploy services. Great. I guarantee you a lot of those are not secure. Right? I remember not recently, but about a year or two ago, when I downloaded a Terraform or CloudFormation template for deploying S3. Well, guess what? From AWS, it did not have all the hardening things in there. It did not tell you this to turn on version control. Did not tell you to encrypt bucket, right? I mean, there's a lot of things that you got to think about. Other external code artifacts. So those of you who've heard about TJ actions, great example, right? It's not just so going back to supply chain, external code can come from in the form of a pre-built CI/CD pipeline script. In this case, those people who uses GitHub Actions as a CI/CD system from GitHub, you can download build workflow code like in the form of an action. So TJ Actions is that supply chain attack in March of this year was where the attacker has compromised the public repository of a CI/CD workflow script called TJ Actions. So those who downloaded that, the CI/CD build workflow was susceptible for attacks. So just to show you the danger of supply chain, right? Software supply chain. So pipeline configurations, build workflows, also the exposure of secrets and HIs, right? When we think about the modern microservices with the cloud native applications and the APIs, all these artifacts, even during build phases, when you do CI/CD, right? The modern way we develop software, when you go from building an application from raw source code to a compiled, runnable, executable application, usually in the cloud, you need credentials to access those cloud environments. You need credentials, right? Environmental variables, credentials, non-human identities to be able to access certain things. So the fabric of secrets, access keys, API keys, and other non-human identities, all the weaknesses where get exposed. Also think about that, right? Vulnerable plugins. There's still people probably doing Jenkins on-prem, right? And all these plugins also full of vulnerabilities, right? And not well known in 2025, there's other things going on. I call it the known unknowns, the shadow artifacts, right? So developers come from all kinds of backgrounds, right? And then all it takes is spin up a new repository. Sometimes they're personal repositories. There's a bleed-ins, right? You call it shadow repositories, right? All the APIs. How many people have actually exposure to API security? Okay, half of you, right? So in API security, which I've done in the past as well, one of the things the API security is supposed to look at is the shadow APIs, right? Because you never know what kind of things that people are being exposed to. So I consider those things. Also AI models, right? I think that the organization always catch up, right? Security practitioners. I remember back in the days when I doing cloud security, right? Well, from a security personnel perspective, it's not, when the organization goes to the cloud, you don't know when it go to the cloud. You just know that they were in the cloud. So no difference, right? So I have customers who's, yeah, we got to figure out this AI governance thing, the AI privacy, before we allow mass adoption of AI or Gen AI. The reality is when they do a query, they find out, oh crap, we didn't know that people are using it today, right? So that AI model was being there, that's also the issue. Context is everything, right? So even with AI and non-AI, it's very hard to understand context. Context in terms of like why you write your application a certain way or the missing context. People get so ingrained about, okay, well, it didn't pick up from my pen test results. It didn't pick up from my scanners. Therefore, it's not an issue. No, there's issues in the context that's missing. We got to think about how do we deal with that. And another thing, right? Vibe coding. Let's talk about vibe coding. I work with some of the more senior like senior software engineer staff level, principal staff software engineers say, the big thing about vibe coding, right? This is not too scary, but it's okay, right? It can write certain things, but as we sample more AI generated code or pieces of code, right? AI is not very good today, at least, to understand architecture design, right? So that's why there's a lot of more focus on the system design, secure design. So there could be architecture weaknesses in your application outside of just writing secure code, secure syntax, and a function. How do we deal with that? Threat modeling, for example, is more important. And then how do we look at aggregated risk? Sometimes it's not just looking at one area of the, looking at just your source code, looking at your libraries, looking at your infrastructure. Sometimes you can see a trend of aggregation. Well, this, and I'll show example later, right? If somebody's building a AI big data application, have the connected to Snowflake, great, they have they did not sanitize the input of their function to call up a database. But later on, you found out that, well, you also have embedded secrets in your code, right? So when you correlate both, it's bad data. How do we correlate that? And data security exposures, that's one, it's more of on the, both on the, more of in Gen AI space, where when you're building your language models, all that, right? So you have exposure to sensitive data, right? When you start incorporating what kind of data you use to train the models, as well as when you design certain API-based applications, you get to see some kind of fields where you're taking sensitive information like PIIs. So, and last but not least, unknowns. TJ actions, great example. How do we detect that there was actually malicious activities? You gotta understand what normal baseline is. So a lot of them is anomalous, behavior-based. And then there's risky changes, right? So I keep talking about velocity. Velocity expectation has increased drastically, just from Agile to DevOps to cloud, now to AI. So the amount of changes a day that happens, there's no way you can detect everything. There's no time. So it's also and detect risky changes due to accelerated dev velocity, things you don't know. I'm not going to deep dive into poison hallucinating models. That's AI security, a different topic for a different day. But just know that this is what we're dealing with today, right? So we've got to do something differently. So I'll give you an example, right? Let's deep dive this. This is the foundation. What does that look like, right? So this is a common GitHub code repository of a modern application. Now, before I show the details, just know this is what modern apps people are building, right? Typically the structure. Doesn't mean everybody follows that. There's also a problem with legacy apps that doesn't follow any standards. But let's just focus on the current ones. So you can tell a lot about a software risk by just analyzing your GitHub org structure. On the left-hand side, you see the typical team structure breakdown GitHub organization. We have you have different teams that have different permissions. On the right-hand side, you get to see that typically, this is what you're dealing with. You might have, under the GitHub code repository, you might have repos that's more monolithic. They call them monorepos. You have repos that's more of a modern polyrepo, right? Microservices, a lot more like that. And you have, all of the above. On the left-hand side, just look at the permission roles, right? You have those different type of roles. Do they have the right role? Do they have the right permissions? One example here, you see that, should the contributors have, what level X do they have, right? Should you be able to commit to protect the branches without any checks? Should you require reviews? Those are the configurations by default that people often misconfigure. That's kind of the door open to supply chain attacks. Do you require status checks? Back then, when I say between 2015 to 2020, when people start with fail to build, let's put some security gates in CI/CD pipeline. But how do you know that those checks are not being bypassed, right? Everything you can tell by just looking at GitHub configurations. Do we trust the roles permission of developers? Having not too much permissions in the GitHub repositories. Every organization that have like a big zero trust initiative, they focus on infrastructure, endpoint data, IAM, but they hardly look at developer permissions, right? So another thing to think about is we gotta really look at shifting the zero trust principles into how we're managing GitHub permissions or code repository permissions. On the right-hand side, right, on the code repositories, I told you there's different kind of repositories, different challenges, but looking at it typically repositories, right? Look at all these little subdirectories. Again, this is a comment, not always like that, but think about the amount of information that's in here, right? Typically, we look at just looking at the source code, part of the source. You can do a scanning, you conduct your static, dynamic, software composition scanning. Great. But what about, your tests, right? You can look at the test coverage. Looking at, are there any unit tests, integration tests? You can look at any scripts. This is where the nasty things of embedded secrets, access keys happens in there. Maybe overlooked if you're just scanning source code. Looking at the configs, that's all the nasty things happening, right? Sometimes the configuration is where the misconfiguration happens, both for your build pipeline as well as your potential infrastructure. And there's could be infrastructure layer, right? You're looking at your IAC templates, your deployment manifest, your Kubernetes manifest. That's where misconfiguration happens. Disclosure of protected secrets happens. And looking at the workflow itself, right? The CI/CD, for example, your build workflow. There could also be opportunities for misconfiguration, scaling out too much issues, right? Co-owners, that's interesting, right? Like we oftentimes think about let's detect issues, but how do we actually have a goal management, right? How do we get that to the right people, right? And famous results is a pen test results, right? How do we get that to the right people? Well, it's all here, right? Wouldn't it be nice to be able to have that inventory visibility, the co-owner of that repositories, right, early on? So that's just tell you how much is hidden in this risk that if being exposed, that it can be leveraged in a very bad way. I'm gonna go quickly on this one because if I would think about the last 10 years since we started DevSecOps, right? It's really just been these 4 things. Those are the common failures you gotta learn. And if you're just starting your cyber or AppSec career, you might have heard about, okay, let's do shift left, let's break the build, let's embed security early in the software development. Those are great cliches at this point, but the execution, the actual way to doing that in the right way is very challenging. Historically, you saw my last example, right? Typically, we don't have holistic visibility across the environment. In a typical organization, there are different development teams, groups, internal, contractors, onshore, offshore, different type of apps. Usually you have to go team by team to understand what they're doing, right? And who has ever experienced a perfect CMDB? Nobody, right? Does that exist?
No.
Doesn't exist, right? If CMDB is not great, right? Then how do you even know what application you have, who owns it, right? So that's always a issue. You gotta find a better way to be able to discover these applications automatically without relying on static tracking system like CMDB. Incorrect shift left, right? Rush to fill the build. The one size fits all vuln management doesn't work. The whole let's fail on critical highs doesn't work anymore because there's so much contact missing in critical highs. And one scanner can be very different than other scanners. And there's so much nuances when you get to that level for those who have done vuln management. And I think overall, we're getting better at fixing new issues for those who's trying to tempting guys put security gates early because now your applications, if you're doing it the right way, you can mitigate, but we still have a problem, right? When you do a baseline scan or anything going to a sizable organization, there could be thousands of backlog security vulnerabilities existing. What do you do with that, right? That's what we need to focus on. How do we should do things differently on that? Last but not least, always more tools. I work for vendor now, but I blame vendors for this one, right? Because vendors want to consolidate, right? But the thing is, as a customer, right? And one thing, and I want, this is where getting to the people aspect of it. there are different owners of security tools. I'll just give you this example, see if that resonates. The security team obviously owns a lot of tools. But I've seen larger organizations in a security organization, their vulnerability management team that could own the VM tool or DAS tool, which is kind of odd. But the AppSec team owns other set of tools, like SAST and SCA. And you have DevOps team who owns certain tools too, because you're talking about GitHub, right? It's not to pick on GitHub or JFrog or any, you name it, right? They all come up with their own scanners. That makes things a little difficult, right? So you got this tension between DevOps or Ops and security. Well, because my vendor told me to wine and dine for things that can do everything. So that creates a tension. So as consumers of those tools, right, developers or security practitioners, you got to live with what organization tell you. So in this case, there's more challenge. So many tools. What do you do? How do you actually consolidate these findings, truly make them consolidate them, correlate them, deduplicate, right? There's a real issue. How do we look at, make sure that those tools hopefully minimize the overlap? If there's overlap, you can actually a way to fold them in, but really extract, distill the context that's needed across all these layers. That's a real issue. I'm talking about how do we do it. All right. So let's focus on the how, right? So really, in a modern way, going forward, I would say that there's really three areas we can actually think about which we should pivot to. We got to focus on speed, right? The speed has many contexts to this. How can we do AppSec in such a way that we don't really slow things down, right? Do at scale, right? That includes of detecting the risk real time versus, okay, let's scan, let's interview an app team, figure out what they have, right? That doesn't work. Coverage, how do we make sure we have end-to-end coverage, right? More tools doesn't mean better. But I showed an example of the GitHub organization. How do we cover all these layers, right? How do we do at scale? We can no longer wait a few years for adoption. Again, I've done this as a practitioner. You know, we often start up, I mean, have success, the program I helped build, but usually start with a pilot, right? You build a pilot program, you incorporate your security program, AppSec program, you pilot a couple of dev teams, get them adopted, get them to advocate, and you scale. The problem with that is you have many different teams. By the way, there's more teams, right? More people writing code, not just devs. Could be anything now. It takes years. So how do we do at scale that doesn't really take years to surface risk? How do we do it much quicker? Last but not least, the biggest problem in AppSec is context, missing context, right? How do we deal with the context upfront? Well, this is how we do it, right? Again, vendor neutral, but when you think about the core ingredients, capabilities, right? And there are technologies out there right now, right? Just how to consume it. Let's think about holistic visibility, right? How do you in such a way today leveraging combination of technology and processes to accurately inventory your application, right? When I say application, that's the apps, the repositories, the projects, the teams, commits, branches, inventory everything and map out the relationships in your SDLC. Got to do that upfront. How do you do that at scale across the entire organization, not just team by team? How do you accurately map out the software supply chain? The dependencies that every piece of your artifact across your software factory is used, and trace it back to each commit, each branch, you know, all over the histories, right? It's there. But how do we consume in such a way you can tell the right pictures up front? Called holistic visibility. How do we do the full coverage? You need to have full stack layer detection, right? Doesn't matter what tool you use. But you want to make sure you don't just focus on scanning the source code. A short example, looking at everything. But you got to play nice, like I said. You got to go after organizational politics. Unfortunately, you might have tools forced on your throat. That's reality, right? You might not always get to choose. You might protect your tool, but the dev team might say, well, okay, but I'm used to this tool, I want to use it, right? What do you do? So you got to be able to kind of work with that. Don't let different tools be the added layer of complexity. How do you play nice, incorporate them, give the aggregated view, right, of risk without introducing more noise, because developer hates noise. How do we actually aggregate risk, right? Because we don't want to think about findings, high, critical, it doesn't matter, it's the risk. Really look at the exposure, right? What is exposure? One of the objections, if you work with developers, is they say, well, this is not a real risk because it's internal facing, or it's just a test dev. Oh, it's in my, in a cloud, it's in a non-prod environment. Oh, by the way, I saw somebody working at a cloud security provider, vendor. A couple years ago, there's a famous attack called cross count privilege escalation, right? So cross cloud count. So just because you have a dev account, cloud account, but you can still privilege escalate your IAM permissions. So it's all that thing. How do you know that, right? How do you know the code to runtime context, right? The thing about shift left is that you can detect risk early in the form of source code, but you might get argument fight back to say, well, how do I know that when it's run, that this piece of library is actually being used, called by runtime? Because when you run a scan of your libraries using software composition analysis, SCA, it's going to be very noisy, right? All the Java applications that you ever build, you're going to have all these outdated libraries, but maybe only 10% being used. How do you get that context? Right? That's why, when you look at it on the vendor side, now every vendor says, we have reachability analysis, right? There's a reason, right? Not to say who's better, but you think about the trend, right? Because people recognize the fact that the vendor community recognize that it's a real issue to deal with noise. So really, how do we prioritize, right? There's not enough time, like I said, not enough time, right? To speed up development is, let's focus on the right things. To the dev, the number one objection or wishful thinking from a dev is, just tell me, security team, tell me what I need to do. Tell me what's real. So I don't waste time. Do it all, right? So that's where the friction happens, right? But, forget about what they call it. We really understand what issues are exploitable, right? One of the things to get down to, can attackers exploit this weakness? Can you answer the question? If you can answer the question, they can defend why you need a dev to fix it. And two, you get a lot more compliance, right? It's not got a term in my head, but do not use compliance as a reason to help tell developers to fix things, but use real data to help them understand why you got to fix it because of risk. And then how do we do it at scale, right? So part of it is think about you need some level of the control, I'll call it the control plane. How do you got all these components working on different layers. So we need a unified orchestration in a way, right? And those of you who are working load management, you want that single pane of glass, at least engine that can do managing results, managing scans, issue out policies at scale, right? It's not just policies that pass and fail. Sometimes it could be deliberate automation in terms of policy automation to say, well, due to our internal risk analysis, we believe that these issues might be flagged high by certain scanners, but we're going to mass deprioritize that based on our own analysis to say, I want to change the severity for these type of issues into medium and low for these particular reasons because it does not apply to us as an organization. But how to do that at scale using some kind of centralized policy engine automation, right? So that is a piece. You can have granular policy enforcement. Very important. Last but not least, doesn't mean nothing if you still just you don't fix anything, right? So in terms of remediation, you got to have things that's actionable, right? And telling theoretically, oh, this could be, but how do we actually fix it? So if you do inventory, if you're going back to visibility and inventory, if you're able to take all the context, understand how things map, who owns what, the co-owners, for example, then you can really get down to root cause analysis, right? The code runtime analysis, figure out that this exposure, you figure out in runtime, or from whether it's pen test results, whether it's from your external edge WAF, right? Or to more fancy, your ADR now, right? Whatever it is, you picked up something's running, trace all the way back to which dev team, which dev, which code repositories. That's what you need to do in order to kind of get that root cause done so you can actually issue out automation for remediation, right? The auto remediation people at vendor tell you, oh, let's automation. Automation is fine, but what are you automating? Right? If you don't know who owned the risk, the root cause. So it's important to make sure that we have insights. So without obviously getting into vendor text, just think about like you need all these 6 capabilities to run modern asset. Now, the good thing is that the tech is there. You just got to be able to kind of understand how to use it. So 3 use cases, I promise you, right? I'm gonna give you a case study. So let's talk about the full visibility at risk. What does that mean? The old way. Now, for those who are starting, that's what you're taught in school probably, or in the best practices, right? You're on board applications, right? And I said earlier, those who run it, you're probably familiar. This is what I used to do as well. You onboard application manually. If you buy a new tool, doesn't matter, right? And then you go to repos, you figure out some pilot teams, right? You onboard the repositories and you start scanning, right? And then maybe basic CMDB cross swap, use what you have updated. That thing takes forever. Small pilot programs, iterate across in years. I said that, I've done it. And then onboard one layer at a time, right? Sometimes you don't want to introduce too much problem. Let's start with, let's say, static scanning, SAS first, and then SCA. Now, some people argue though, SCA first. It doesn't matter. Thing is, typically, the approach is that you do one thing at a time because you don't want to introduce too much at risk. Problem is too slow. Blind spots, supply chain, right? Like I said earlier, right? That's certainly that was a problem, right? It does no good when your build workflow was compromised. Doesn't matter how good you scan your supply chain, or if you don't configure your pipeline, your repo configuration properly, then you can commit to protect the branch without branch protection. So it doesn't really matter if you scan or not. So dev can bypass it. What can we do now, right? We can actually onboard, new ways that with the right technologies, you can onboard inventory repos at scale. So there are techs right now. You can look at a GitHub organization and be able to kind of the tree I show you, right? There's tech right now. You can actually map out all that upfront. So if you have org level GitHub, you can look at all these metadata to give you that map visualization of all your repos, the owners, the projects, the build workflows, the commits, branches, artifacts, ownership, all that in a way that you can actually query and search, show you the relationship. And think of it as that's like a real-time CMDB in such way, right? That is the blueprint. Get that blueprint up front. And that way you can achieve holistic visibility across, the org in really days and weeks versus years. And think about your bill of material, right? So there's a lot of pushes on SBOM, but I would say SBOM is already not important anymore, right? It's not about SBOM, it's about, do you really understand what you have, right? The extended bill of material, your APIs, your AI models, or other dependencies beyond just your software libraries. That is an important thing, right? So great that you push SBOM. How many people doing SBOM?
Not at scale.
Not at scale, right? But great, it's fine, right? But think about this, a lot more than just SBOM. And think about instant org level onboarding. So onboard the org, you onboard the repos, right? You can do that now, right? So you can do it all at once, right? There's some innovation happening, right? So part of it is some modern ASPM, which Cycle is part of, but we're not the only one, allows quick onboarding, right? The ASPM technology, not talking about vendor, just the tech itself is designed for you to do that at scale, right? So I will look at that. And then there are, right, on top of that, one of the use cases is be able to kind of give you software bill of material, but not necessarily SBOM, basically the BOM across SDLC for all the components. So the tech exists now, right? That gives you enhanced visibility across supply chain, right? So you saw this already, right? So imagine the tech that can map out all this instantly, right? So let me give you an example, right? This is a couple screenshots. Let me take you through a practical example of a client that, again, this is not the pitch cycle, but show you example. So this is a customer I just helped with a few weeks ago, right? I mean, they're concerned about AI applications. So we ran a query of detect all the AI technology that they may or may not know, right? We look for OpenAI, AWS, Azure, GCP AI, Claude, Hugging Face, right? And then we found all these instances, right? So this is where the BOM happened on the right-hand side, right? I redacted the customer on the repositories. You can see kind of all these issues, right? So understand all these texts. Totally well, right? And we visualize the map. How to read, that's fine, but I want to deep dive, right? So how do you actually do it, right? Imagine, it doesn't matter what tech you use in the back end. So imagine you have now information, understand the AI. So I was helping this customer do a little bit of investigation, a little hunting, right? This is not the same threat hunting from a SOC. This is hunting your AppSec and your SDLC. So I looked at all of them, and I found this particular repository that have AI, I think maps to Azure AI, right? You know instantly in my head, or as a practitioner, a couple things going on. All right, this repo, this project, I think I redacted, but it's the BE. So this is a global company. I think it's some team in Belgium. Couple things in my head going on as a security practitioner, AppSec practitioner, and for those of you who are thinking about this, is okay, well, you have a team building AI applications using this Azure AI. Maybe they're building in Azure too. So I think about not just AI, I think about you're in the cloud as well, right? Azure cloud. So I think about that as like, there's only things in my head, okay, crap. Not only I think about the application itself, I think about, are you using AI securely? Are you securing your Azure environment? So you should be thinking about that instantly, right? So let's keep looking, right? So I click on this, I go into this repository, right? And I show you this, right? So obviously I redacted. So this repository have a couple of things. This one has Dockerfile, right? So we know it's an active project, right? By looking at it has Dockerfile, it has APIs, has workflows, has container images. That means this is being built already, right? And then repository owners, right? I redact the names, but I want to show you that it's a bunch of team working on it. And then I redact the name, but you see global DMT contractor. So we know that this contractor one just like, okay, crap, it's not just internal. And then we have labels, right? So active, Dockerfile, API, CI/CD, and it's source Azure DevOps, right? Get it from there. And it's a private repo, it's great, but is that a shadow repo? So all these things, you gotta ask yourself that question. It tells you a lot about that, right? And I look at the what text they use. I see a lane chain, right? So I can follow on what other text they're using in this repository. Lane chain, right, which is another AI component. You can see LangChain is actually an open source framework designed to simplify the creation of apps using LLM. So to me, I know that now this app doing LLM. So you got to think about, okay, now you can see LLM, right? So, but also looking at what other text, you can just give you an idea, the risk profile. So my point earlier is that you got to look at AppSec as a holistic thing right now, right? So looking at all these things, this gets more interesting, right? APIs, right? So this one's API facing. You should instantly thinking if I have APIs, probably have all the API exposures. I think about APIs, think about like how do you connect those APIs, probably are they securing their access key secrets? But this one, this post generate API, right? This API here has a pull request merged, production release, 13 August. I told you this is real data, right? It's recent. So you know it's active, it's dangerous, right? This is not just a test project. So again, it can tell you a lot about that, but my whole thing about takeaway for this is that you gotta look at everything holistically. And then sensitive data, I show you, right? So you can see that there's PII in this, right? Because when you think about building LLMs, you think about, I told you earlier about sensitive data. So, I mean, there's only like a name and email, but really, you gotta ask yourself this. Did this really comply with corporate data security and AI privacy policy? Maybe, maybe not. But you gotta have that mindset now with modern application security, right? Potentially exposed sensitive data. Look at the packages, right? Certainly, and I suspect, again, as an AppSec engineer, that people building this may not be security developers. They're using packages that have a low health, right? Those are, we're not even talking about vulnerabilities. It's bad practice to use legacy outdated packages. So the overall health course tells you that, yeah, you know, it just, if anything, I mean, put this group on a close watch, right? Again, tell you a lot about that. And this is what I mean, right? Looking at things holistically as a layer. So you see this repository, when you scan, compile all the data, there's SaaS related findings for like not sanitizing inputs. There's branch protection was disabled. So if you were to just enforce scanning, you can, you know, it's not enforcement of gate, you can still commit to protect the branch. And yeah, SQL injection, secrets, right? I told you about secrets. I told you, like, think about, I'm just worried Azure and open, and LangChain and LLM, right, just the sequence issues. I'll show you how to correlate that. But access, user, privilege, permissions, everything I talk about now all in one place. So what does that tell you? When you think about a modern application security looking at like just AI application, think about the dev team who's building that. They're not security developers. But it's not about you look at one particular issue. It's about everything, looking at everything, right? Because it tells you a lot about, when you look at everything so far, I hope you have come to the same conclusions I did. The people who building this probably don't know what they're doing, right? But how do we look at this holistically to see how one risk correlates to another, right? That's my point about the holistic risk. Any questions? All right, so if there's more to that use case later on. The second thing is, how do we do it in such a way? Well, let's think about net new now, right? Net new application, because we're building new applications all the time, especially the new AI application using live coding or any kinds of AI code assistance quickly, right? They want something, they want a MVP, minimal viable product in production in 5 days. What do you do? Okay, the old ways, right? Again, same thing, onboard newly security, scan a part of CI/CD build pipeline. Those who's fancy probably scan it, the source code during pull request, which is a better approach. Either way, you probably want to scan all changes manually, so it's really slow. What we need to do for the new way, right, especially for new applications, I mentioned about the architecture weaknesses, we need to start on the design phase, right? Especially when we talk about AI assisted threat modeling. So prompt engineering is an emerging practice. You can actually prompt your LLMs, give prompt instructions so that even if you use AI code systems, it can produce better source code. If you give it prompt rules of what to follow, secure coding guidelines. So that's what you can do now going forward, right? Really learning, for those who are starting your career, want to pivot into AppSec, highly recommend getting into prompt engineering. How do you prompt the LLM to write secure code, right? That's number one. But threat modeling, architecture review is also very important, right? That's something that vibe coders cannot do. So relook at the architecture side of things. I mentioned auto discover on board, right? Everything I talked about, do that upfront. As soon as a net new application being formed, that means there's probably a new repository being created, a bunch of owners. You should have visibility on that, right? So correlate that to your risk. Try to follow pre-commit hooks as possible. IDE, pull request. I think IDE was a highly disputed an area for a couple of years in between 2015 to 2020. Some argue that, IDE, well, a security team cannot really see if developer using IDEs or not. I was at AWS reInvent a couple of years ago when I was talking to AWS internal DevSecOps team. They said that they fully adopt IDE because they think that the more they fix earlier, the less they do later. But now there's technology out there that can measure adoption of IDE plugins. That's a good positive. But also tell you that technology innovation has made IDE adoption easier because a lot of the legacy tools out there, this is not talking about any vendor specifically, typically is, the scan happens, right? It was designed to scan compiled binaries. So sometimes the IDE releases on early days with a different engine. So when you use IDE and looking at like the scan later on doing CI/CD, CLI, you get different results. But that's not the problem anymore for modern technologies, right? So if you have vendors who have one engine under the hood for IDE, CLI, or pull request SCM scans, then you have no problem. So I definitely recommend go as early as possible. You probably want to do pull requests versus later on CI/CD build pipeline because there's so much things wrong. So when you do pull requests, scans for net new applications, the psychology wise, right? A developer are way more likely to comply because that means, hey, that morning the dev just wrote something new, or I just tell my co-pilot to tell me something new. I feel good, I commit, I want to see my code get merged. It's way more incentivized for the dev to know, hey, okay, I gotta fix this issue versus later on, I did that, and later on, when this build phase happens and there's issues later on, oh, crap, I gotta go fix it, right? So psychology-wise, it's way easier to do early. And you want to be able to do it asynchronously, right? So if you just do scanning, you can't just do 90 scans anymore, right? How do you actually especially when you're making changes, right? Sometimes net new doesn't mean net new applications. It could be a new change just introduced to an existing application. How do you do such a way you don't want to trigger all these rescan of the whole thing when only the change is minor, right? So now this text can do that. Leverage runtime validation is a production quality check, right? So this is, I see sometimes organizations still use static scanners as a way as a gate for production releases. There's a lot of risk to that because one, using that static scanner meant to be do earlier to later on, but there's still a lot of noises. No static scanners are 100%. Nobody. Or for vendor, nobody's accurate 100%. You want to make sure your production release using at that point, right? The last events, only using runtime is a way to see, okay, let's just do the final validation. All the checks should happen earlier, right? So using runtime is a way to, as production quality check, because things are picked up at runtime, typically it's very hard to argue against by developers to say you got to fix it. Branch protection, block merge, so the things I'm talking about is, yeah, you got to protect the branches. Right? This is the supply chain configurations where you want to prevent the devs be able to kind of bypass your controls. Right, so modern scanners, right? And so another thing about tech innovation space is that now there are new players out there. The design is meant, the scanner is meant to do it very, very quickly. And there are innovations out there that scan can pick up a lot more context than traditionally like rule-based. Like when you think about static scans, things that developers argue with you. Again, not talking about any vendor specifically, but typically there's a different layer of the scanning, right? You got they call it the spell checks, linting, only looking at the syntax. More sophisticated, you got rule-based, you write rules to check for certain patterns. But now there are more of a data flow analysis, right? There are more and more advanced scanners now that can build a data flow source to sync and looking at the cross-reference different files, different functions, be able to have the depth necessary to look at, context data usually missing. Sometimes based on the tag, we can get into business logic risk as well. So encourage to start looking at the way we can modernize everything, right? Again, this is not a vendor page, just telling you what's out there. And also it's 80-20 rules, right? If you want to modernize, the biggest objection is that, well, we have all these languages, all these frameworks, all these legacy apps and modern apps. There's no tool that does everything. Right? My recommendation is always the 80-20 rule, right? Most organizations are moving towards a more modern size. So if 80% of your current stack is more modern, then you should probably have a program and tool, technology processes on those 80%. And the 20% of the legacy have a different approach to it, right? Versus trying to just focus on 100%, then it's not one size fits all, right? So that's one of my best recommendations, pet peeve, is that don't let that 20% affect the strategy for 80%. So visually show you an example, right? This is not to promote AWS at all, just an example, right? I mentioned about legacy. You have ID scan, different engine, different results. You got a pipeline scan, right? That scan all these artifacts. At this point, if you scan a pipeline, you may or may not have visibility into where the code come from. Because the build pipeline, it might not have that metadata tagging attributes to which repo, which team, which is why if you do this legacy way, it takes longer to triage, figure out who owns it. And when you do black box testing, there's no correlation, right? How many people have tried to correlate DAST and SAST? Is it easy?
No.
Or pen test results, find out who owns the risk, right? So that's what the world we live in. We can't do that anymore, right? So just manual correlation is very intensive, very hard. And you can never hire enough people. So can't scale. So what do? Modern approach, right? Same engine, but now, using the control plane and the ASPM technology, all that, do as much as IDE scan as possible, but gradually increase, right? Scan repos, right? Scan raw source code as much as possible. Use same engine, right? Same policy, like I said, unified policy orchestration so that, as you progress through SDLC from your local machine, IDE procurement hooks to a repository to build, by the time we get build process, it's pretty much most things should be fixed for net new. So if you do, it's just catch up, right? But same engine, same policy. If you focus on have a good policy and practice happening by then, by the build test phase, most of the net news already probably risk has been surfaced. If you don't have time to fix it, or you want to create exception at that point, the risk has been accepted versus slowing down in the build phase. And then, for all your runtime correlation, you can use automated correlation, right, as much as possible, using a tech like ASPM, all that have a code to runtime context correlation. So there's a tech out there, you can take a runtime finding, whether it's WIS finding, or whether it's pen test finding, or DAS finding, API security finding, and correlate back to who owns it, which repo come from. So there's techs out there right now. Number 3, this is the legacy, my favorite, probably the favorites of our vulnerability management team here. What do you do with the existing backlog, right? That's a common objection. I have so many these issues. Well, just do criticals and highs. I have a Fortune 50 below customer. We even just during POV, we did just about 20,000 repository, which is very small, 100,000 repos. Their SCA, or third-party library finding, across the 20,000 repo pilot, was 700,000 findings. If I filter critical highs, there's still 300,000 critical highs. There's no way you can fix 300,000 critical highs.
Do you have out of that 300,000 criticals and highs, are there some common packages that are, at least the majority of those though?
Yeah, so good question. So yes, that's pre-filtered, right? That's just raw findings.
Right.
Once you add in the same packages across different texts, once you look at the ones with fixes, without fixes, once you look at the ones with exploit maturity, mature exploits, the one that's reachable. When I filter all that down with the right tag, you get down to sub 1,000s, right? But that's what you need to do. I think I might have an example later on that. But yes, exactly, precisely, right? That's why risk contextualization, prioritization, very important for existing to figure out what you need to do. So here, right? Chasing issue from each scanner independently, that's the common issue. When you aggregate scanner results, every scanner has opinion. And then all of a sudden you can deal with huge loads of backlogs. And don't prioritize based on severity anymore, right? Every form of risk scoring, CVSS, which version, 3 or 4, there's been a study a month ago, white paper, talk about like nothing's perfect, right? So never rely on just severity. Another one, not too deep dive, but this is more of a people process. I can just have separate talk on people process. Another way, right? And this is more on the people side of things. Not involving engineering when defining remediation policy. That's a common factor. Like loan management team do their thing, but when dealing AppSec, the best practice is that when you create those policies about pass and fail, SLAs for remediating, just even for libraries, you want to involve engineering leadership. Sometimes involving them, defining, okay, well, if it's a direct dependency, if it's major version upgrade, if it's a minor version upgrade, what can you commit to? It's way easier if you reconcile that upfront with engineering team versus trying to define that in a silo. I want to call that out because I see that a lot. And only measure mean time to remediate, which is a very good metric, by the way. But that's not enough anymore. I'll show you why. And generic SLA, not a common bad practice, right? I mean, for VM, it's fine overall, for enterprise vulnerability management. But for AppSec, you got to be more specific, certain SLA, because there's so much complexity in terms of impact on breaking fixes when you want to fix certain thing in application development. So factors and nuances, right? So what do, right? We want to analyze all issues, group class issues, prevent custom. So basically, look at all issues. We have to group them based on classes of issues. For your custom code, your OWASP top 10 type of findings, rather than look at them individually findings, look at them as CWEs, classes findings. You have tons of issues, could be the same issue, like insanitized inputs, it's just input validation, right? All kinds of injection attacks come from the fact that you're not sanitizing inputs. using the group them as a same type of issues for, you mentioned earlier about SCA, right? Look at the library themselves versus looking at findings. So there's a way to group them in such a way that makes sense. Look at exposure, right? Don't just look at the finding, right? How do we objectively look at this finding? It doesn't matter what severity that the vendor, the scanner assigns it. What is the exposure to your organization based on the impact of the application, business impact? Looking at the runtime exposure. If this library is actually being used in production, if this SaaS finding of this application is public facing, or what are the conditions to make it public facing that you may or may not know? Were there any infrastructure misconfiguration that can render this internal application public in an instant? This is why we look at like cloud, right? Cloud is very dynamic. We have to tie in infrastructure configuration, the lens infrastructure configuration to application risk exposure. And prioritize based on exploitability, right? It's essentially how easy to exploit this. What's our business impact? What's the fixed complexity, right? That's a big thing. When you think about modern VM, role management, you got to think about the complexity to fix based on how much time you have. And you can reconcile the right agreement with your dev teammates so that there's low friction in terms of setting fixed expectations. And this is not a deep dive on security champion program. How many have heard security champions program? 2, 3. Basically, it's one way to get engineering, software engineers, development team, skin the game. You want to turn some of those high-performing developers as security champions who can be self-sufficient. But the thing is, one of the things I see happen a lot is when people building these programs, they focus on enablement, teaching them security DevOps training, but you don't give them empowerment, meaning that you don't really trust them, right? Oh yeah, you go through this training, I give you a sticker, I give you some incentive, go fix it for them. But then security team don't invite them to help defining policies because they're closer to context than the security team, right? So tips here is that for existing backlog, for the champions, those who have champions, they understand what it takes to fix things, involve them in defining policies. Another thing is to separate prod and non-prod issues, measure cumulative trends of issue identified. So one of the things that, that's a sometime board level conversation, right? So security team, you want to kind of show that especially role management, you want to show your leadership that you're moving the right direction. But just measuring mean time to remediate doesn't really give you the context of saying how much, it's like, you can always have more findings, right? The backlog of vulnerability always gets up. But how do you kind of show progress? So you want to be able to measure vulnerability prevented in pre-production and vulnerability reduced in backlog in a way that shows progress. So, but part of being able to do that is how do you actually separate prod and non-prod issues, right? So, let me see. Okay, so one of the metric I didn't have it here is how many have heard vulnerability escape rate, VER? Okay, great. VER, vulnerability escape rate, is a next level of metric above mean time to remediate that actually tells you, are you fixing vulnerabilities or findings faster, at a rate faster than you're introducing more issues. So how do you measure that is the vulnerability prevented with the shift left pre-production, right? If you fix 10 issues in pre-production when you set the right gates for net new, and so let me backtrack. If there are 20 issues in this release, you fix 10 out of 20, 50%, because you don't have time or other reasons you want to give people more time to fix the other 10 because the fix complexity is high. Okay, you're adding 10 more to the backlog, right? You fix 10, you put 10 to backlog. But if you're fixing your existing backlog, if you fix 5, that means just add 5 more, right? So the floodgate is still open, and then you have more to your overall depth vulnerability count. But if you're able to fix 15 existing, and introduce only 5, over time, your backlog will reduce. So the lower the VER is a measurement of that, the more it can demonstrate to leadership that, hey, the program is improving. So that's kind of what I suggest the next level, using VER. I don't have a slide here, but I would encourage research that. Speaking of that, so that's a real example, right? This customer here. Start off with 700,000 findings, right? Just give you a prioritization for SCA, and filter critical and high is over 6 figure. I don't remember what. But if you're just looking at the ones that are reachable, that means it's being called at runtime. That's only like 4,500-ish, right? Out of 700,000 that's actually being used in runtime. And then if you're looking at exploit maturity, right? So using common the exploitability prediction scoring system and assesses no exploitable vulnerabilities. We're looking at these databases. We're looking at exploits only mature, likely to be exploited. You only get down to 1,500. Now, I just show you, you can do a lot more filtering than that. But just to show you, this is kind of how we address our existing backlogs. The last part of this is I want to show you, remember I told you about the case study here, right? So remember the AI application? So the second half of the investigation, as relates to the backlog, is that, so when we look at this AI application, right, I showed you earlier that it has different layers, risks. That's interesting. Let's look at this SAS finding here, right? On the left-hand side, you see there's 3 critical SAS findings. They all fall under the injection, right? SQL injection, sanitize external inputs in SQL query. If you look at that, oh, SQL injection, critical, let's fix it. But before we do that, let's see, is that a real issue? So on the right-hand side, you see, right, all 3 are OWASP, 803 or CDB 89, right, injection. But inspecting this one, look at the name of this, right? It's sync DB from Snowflake. What's Snowflake? Data platform, right? So instantly, okay, so this is probably talking about a code in accessing Snowflake. Right, so that's kind of, you think about in my head, that may or may not be exploitable because it might be a private, so it might not have an input. So if you look at this finding, specifically this SQL injection finding, right? I show you this, inspect this Snowflake Python artifact, right? Snowflake tell you a little about its interface data lake. Now, usually it does not require user inputs, but let's just investigate. Yeah, I tell you all these factors, right? We cycle gives it risk score 91 because it is a CDB top 25, OAuth top 10, critical severity. Those things probably constitutes, right? But now looking at this exactly, cursors.xq query, right? So you can see, right? This query is not sanitized, right? Really straightforward finding, right? And I mentioned here, right? People built this likely might be data engineers. They're not regular developers. They not know, but before we figured out how do we know it's exploitable, right? Using concept I talked about. And this is not library, this is custom code, SAS finding. So how do you defend this, right? When you go to this data engineer, just say, hey, you need to fix this. But the guy gonna ask you, or gal ask you, okay, well, why is that an issue? Well, how do you explain that? So now, this is not to promote our tool, but we look at the exploit analysis. We use AI, but in a way you can look at like deep dive. You can do this manually, right? You start looking into the exploitability of this, right? You can do it manually. The get Snowflake credential on the right hand side, you see that get into the source code here, right? You see this query right here. But look at what I highlighted, right? Actually using this is not, there's no user inputs here, right? So, but the get Snowflake credential function using environmental variables store sensitive information. So this means that, wait a minute, even though this may not be a exploitable SQL injection, but this actually have this function actually stores environmental variables, so it might be a secret issue. But they also talk about, like, if you look at, you can do it manually again, you can look at API endpoints, right? The fast API application handles inputs. So that tells you, hey, it may not be SQL injection exploitable because of the user inputs, but this raises a question. We look at this is like, What about SQL issues? What about the API issues, right? So let me look at here. When you have everything in one place, let's look at the secrets. Indeed, the Snowflake application actually have hard-coded secrets here. Like I have mentioned Azure AI, right? So not only have the access token here, you got OpenAI API key right here, clear text, right? And then you have Azure OpenAI, and then you have Salesforce, Snowflake connections on there too, right? So I show you this to say that sometime when you look at all the aggregate is finding, you may or may not, you can probably infer what real risks are there. In this case, the SAS finding for SQL injection might not be applicable because it's a big data platform. It does not require user inputs to, to send a database query. However, because looking at everything else, it looks like a big data application, building AI, and with developers may or may not know what they're doing. You have having all those risk layers at the same place. You'd be like, okay, let me investigate this and that. You can see that, okay, we've triaged SAS finding that may not be exploitable. We can downgrade severity of those, triage the noise, but the real risk is actually credentials, secrets, right? So kind of walk you through this example to tell you that the power of prioritization, the exploitability analysis, and why we should look at AppSec risk in a layer way holistically, so you can actually pinpoint the real issue. Hopefully this makes sense, and that's it. Yeah, that's my, I know my time, okay. Questions? Yes.
So some of the questions, just to comment. I agree with pretty much everything you said. It's not surprising. But I think something that gets left out of this conversation a lot is a proactive approach on the development side, right?
Yes.
Like you can have as many alerts as you want within pipelines and code reviews and all that kind of stuff. But really the thing that in the organizations I've worked with, we've had really good, secure development processes. The information that you're getting out of the systems like you've got here being funneled back to a developer enablement kind of program.
Yeah.
Where they're building out kind of secure processes by default. So you don't have a situation where like a developer's building something, they get an alert. Can't use this version of this library because it's got vulnerabilities. But if you're on the security side, seeing all these findings coming in, taking that back to like a developer enablement team and they go, okay, well, so we need to build like a base container.
Yeah, thank you for saying that. Yeah, I mean, that itself. So absolutely, right? I mean, this is obviously with time purposes. In my other talk, and I think in my last OWASP talk, somebody brought up container, same thing. This is it's still reactive, right, in a way. But to your point, we want to shift towards more of a secure by design, secure by default. Using hard and secure baseline is absolutely right. Container image is a good example. I'm a big fan of, I think we have a veteran as well, right? And I was involved in DoD DevSecOps. Part of it is DoD built what's called a Iron Bank, right? They have all these pre-hardened repository, big pre-hardened container images, all these controls. That extends to pre-hardened IAC templates, pre-sanctioned libraries, separate, exactly to your point, right? That feedback loop should gets back to developers. I mean, this is just a context identification. Okay, these are the things that we see. But to your point, part two of this is, okay, what do we do to prevent that happening, right? So one is find and fix, but then find, fix, prevent. The prevention part is over time, when you see this consistent pattern, when you see, hey, this is top container images, container image issues, we need to, and that it tells you, hey, this is a widely used container image. Let's build a secure baseline and put into that, right? Same thing with libraries. Same thing with, there could be certain authentication patterns that you want to, pre-write, right? Library. Yes, absolutely.
Yeah, I mean, that's what I've seen. It's like, if you give a developer a secure platform to build on and secure processes to build with, they're not going to complain about security.
Yeah, that's the overall goal, right? I mean, that's a talk by itself. Now, we should definitely strive to that, but our point is like, we got to make sure the people process follows it. I can tell you, when I was a consultant, I did a big container security project. Because one of the big four tell the client, here are the controls, this 800/190 controls, you got to secure base images. But it turns out, securing base images itself is a very difficult thing to do, because you got infrastructure DevOps team pushing back, okay, who's gonna build that? And then what are we doing, right? There are, like, it's easy when they're big Red Hat customer, they have Red Hat universal base images, UBI. But then, well, do you really need Red Hat, right? I mean, so there's a lot, but good. So I always encourage, start that conversation. But work the people process side of things out first. Anything else? Great question. Comment.
Have you ever seen AppSec programs integrate something like you guys, what metrics would you use? Have you ever seen a successful implementation of monitoring code coverage metrics that the developers would use to code? To say, how many lines of my code repositories have I tested effectively? And the reason I ask is because I'm a big fan of doing that and including that in like AppSec goals. Because I want to push back on a typical argument that we get here all the time of, well, I can't upgrade that vulnerable package from third-party component because it's going to break my application. Well, ma'am or sir, like, you have no proof of that because you haven't even covered test-wise your repository. It lowers that mean time to remediate, and it improves some of the other good metrics that you mentioned, wherever developers follow good development practice. So just curious from your your experience. Have you seen
Absolutely.
something like that
Yeah. Obviously, I'll include a little bit limited amount for this, but yeah, I think from a metrics perspective, I mean, the DORA stuff is always good, right? Beyond security, when I think about AppSec coverages, there's some metrics. Some metrics got to be direct in line with dev metrics, DevOps metrics, and code coverage, test coverages are perfect examples. Holistically speaking, metrics, having those is perfect. I mean, that use case is great, but there should be other reasons, right? Just because you scan the code doesn't mean, you're complete, right? Because the coverage might be low. So yeah, absolutely. Code coverage, test coverage are those both are really good metrics.
Yeah.
So you can use your run down in your app and you show the test coverage you've had, what the critical vulnerabilities you have.
Yeah, I mean, again, that also depends on the tool that you use, right? And sometimes we have no critical highs. Are we ready for production release? No, because your coverage is low.
Yeah.
Right? So because those things not covered doesn't mean there's no risk. So yes, absolutely. I think we see that used also as a pre-production release. Okay, we're gonna have to gotta achieve some level of coverage.
Excellent.
So what kind of trend are you seeing with vibe coding now? And, we have non-developers developing code. Are you seeing more vulnerabilities, or are you seeing more secure code being pushed out?
That's a great question. I think there's so many discussions on this in the last couple of months. I think it's mixed, right? I think that it's not necessarily more vulnerability. Yeah, in a way you can say it is, but I'm not a fan of like the FUD, right? Scare tactics, don't use it, right? I mean, I don't like to be scaring people, right? But I think it's here. It's all about how you use it. I have a lot of people I know who are doing the dev, right? Not just security side. I think that it's mixed. If not being used properly, there could be more, but it's no different. Like, there's nothing new about the vulnerability itself. It's just that more, right? In terms of volume, and pace,
More faster.
more faster, right? So, that's why I keep going back to prompt engineering, right? And one of my good colleague friend who was speaker at one of the Southern California AppSec events, Jim. He actually talked about prompt engineering, right? So you can write code, but if you prompt your co-assistant, AI co-assistant with the right prompting, and this guy he showed like 5 most common AI co-assistants, just to see how. I mean, the result's pretty good. I would say that if you, with the right proper prompting, with the AI prompt instruction, probably write better code than average developers in terms of secure code. Doesn't mean quality code, right? Different. But I think the issue for vibe coding in practice, the issue of vibe coding, not just security, right? This is talking with senior developers. Issue of vibe coding is that code does not make architectural sense. So that's why I'm not, at least people I talk to, we're not seeing adoption to the fact that it's getting to like, people use the vibe coding, maybe do some small projects, not important, not business critical. You're not vibe coding your banking application, right? You use vibe coding some new stuff. That's why in that sense, I think it's not a big deal, but the issue more vibe coding is that, again, this comes from senior developers. Vibe code, forget about security. The quality vibe code, it reads like a very, very junior developer, right? So I think there's more issue in that. So we don't even talk about security yet. It's just, that's why I don't see a lot of vibe coding adoption right now.
Sorry,
Yeah.
as somebody, I think that's a really good question. As someone who I am certified in vibe coding through multiple different streams of like learning, because I wanted to learn a little bit more about it. And I think you are right, the volume is going to be, it's already happening. I mean, companies are implementing them in Fortune 50 companies are getting people who are not experienced with code, who are now using AI like ChatGPT, Claude to make simple tools to really complex tools. And so I think that what I'm getting at, what really is going into a question, do you feel, Mr. Jimmy, that, I'm so sorry, sir.
No.
My fault. Or do you feel that with vibe coding more into the future and having knowledge now with security, would there be a chance of implementing security protocols with vibe coding for it to?
Absolutely.
Yes,
I'm a fan of that, right? I think that it's gonna be here. Last year, I was fortunately invited to be a panelist on City Venture. They hosted a conference called Developer 2030, right? One of the keynote speaker, he was a founder of a new from the AI security web company. At some point, right now I'm saying, yeah, we're experimenting, AI is not there, but I believe eventually, is it by 2030, but whenever that is, at some point, it's gonna be AI-led dev assisted. Right now, dev-led AI assisted. But I think it's an opportunity, right? Just like I think that we talked about earlier, right? The cloud was an opportunity, cloud native was an opportunity to do some secure baselines, right? Secure by default. Yeah, so it's hard. But with vibe coding, with AI, or just say AI assisted coding in general, I think there's opportunity to for us as a security team, people, practitioners, to use that AI to again learn proper prompting, to have an opportunity to change, right? Because it's way easier to tell AI to write secure code than tell dev to real human to write secure code. There's no argument. There's no feelings. There's no A. You tell it, give the AI rules, the AI will follow.
Yeah,
Right? I believe in that personally.
Yeah, it's something that I hear a lot when people talk about generative AI code. Is, how do we make it safe? People talk about secure prompts and, better models.
Yeah.
And the thing that I get asked is, well, if you've got a tool that can do policy, code policy stuff, is there a way to connect that to the AI that's doing that generative piece, to kind of put that in a pipeline? So that if you've got, secure coding practices or something that's codified in the tool, and I ask you to build me something like this, can I have my policies kind of injected in doing that check before it does that one? And that would be something that's kind of valuable.
Yeah, you're a pretty good point, right? Because I collaborate with some of the, called the practitioner industry who's really exploring that, this concept. And one thing I would say is that anything is possible. Going back to, this is more of a, mindset, right? As abstract practitioner, I think, we are early. Part of the things I advocate is we got to have that, going back to the roots of DevOps, right? Some of the DevOps principles like being open for experimentation. Right now, with an era with AI is experimentation. That includes in security, or secure